So in this session we are going to discuss about the line of action, the pressure angle and the path of contact. So first of all, let us consider pinion 1, which is a driver and it is rotating in clockwise sense, transmitting its motion to the gear 2, which is rotating about point B. So as both the gears are meshing externally, the pinion 1, if it is rotating in clockwise sense, the gear 2 will rotate in anti-clockwise sense. Now in this diagram, the three circles are shown for gear as well as for pinion. So the first circle for gear is representing the base circle. The second circle is the pitch circle, which is shown by the center line, and the third circle is the addendum circle. Similarly, for pinion, we have got addendum circle. The larger one is the addendum circle. The middle one is the pitch circle shown by the center line, and the smallest one is the base circle. Now I have shown over here the driving tooth on pinion by green color, and the driven tooth on gear is shown by pink color. Now when the driving tooth on pinion exerts the force on the tooth of gear, the force is transmitted along a line which will pass through the pitch point, and that line, if you will observe, it will be a tangent to the base circles of pinion and gear. So this line is nothing but the line of action or pressure line. So over here I am going to draw a line. So a line I am going to draw from the point of contact of the two teeth and passing through the pitch point like this. So you can see over here, line is tangent to both the base circles, means the base circle of pinion and the base circle of gear, and the force that the driving tooth is exerting on the driven tooth is along this common tangent to the base circles. So this line along which the force is transmitted from the driving tooth to the driven tooth is called as the pressure line or the line of action. Now if I am going to draw a common tangent from the point of contact, so let us draw a line tangent to both the pitch circles. Now remember, over here you need to draw a line tangent to both the pitch circles. So like this I am going to draw a tangent over here. So this is the common tangent to the pitch circles. So this TT line is the common tangent at the pitch point. So over here I am going to indicate the pitch point by point P. So this pitch point is the point of contact of the two pitch circles, that is pitch circle of gear and pitch circle of pinion. So the line of action always pass through the pitch point, and the line of action is tangent to the base circles of pinion and gear. Now the angle made by the line of action or the pressure line with the common tangent passing through the pitch point, this angle is nothing but the pressure angle, and it is indicated by phi. So the pressure angle is the angle between the pressure line and the common tangent to the pitch circle. So this angle is indicated by phi. This path of contact is a straight line in case of involute profile, but the path of contact or the pressure line is curvilinear when the profile of gear tooth is cycloidal. So whenever we want to find out the pressure angle at any instant along this curve, then the value of phi will change. So if I want to find out the angle made by the curve as shown in figure with respect to a fixed line like this, say it is common tangent, and I want to find out the angle made by this curve at any instant. So if I want to find out the angle at this particular point, then I will have to draw a tangent at that particular point, and I will need to measure the angle made by the tangent with the TT line. Similarly, if I want to measure the angle of this curve at a particular instant like this at here, so at that instant I will have to draw a tangent to this curve from that point, and I need to measure the angle made by this tangent drawn with respect to TT line. So the angle you can see over here, the angle goes on changing when I'm going to change the position of point. Hence in case of cycloidal tooth profile, the value of phi is changing, whereas in case of involute profile, the value of phi is constant. Now we are going to discuss about the path of contact. So for that, first of all, let us see how to draw the diagram. So over here I have drawn pinion, which is smaller, and a gear which is bigger in this pair. So the smallest circle of pinion is the base circle, then the circle shown by the center line is the pitch circle, and the bigger one is the addendum circle. Similarly, the base circle of gear, the pitch circle of gear, and the addendum circle of gear. Now next step is to draw a line from the pitch point which is tangent to both the base circle, that is base circle of pinion and base circle of gear. So draw a line tangent to both the base circle, and this line will always pass through the pitch point. So over here I am going to draw a line tangent to both the base circles. So the line is tangent to the base circle of gear and the base circle of pinion. The line always pass through the pitch point. Pitch point is indicated by P. So now the next step is to draw a line AE perpendicular to the common tangent drawn to the base circle. So draw a line AE perpendicular to the common tangent to the base circle. So over here I am going to draw AE line like this. So this point is point E. Similarly, draw a line BF perpendicular to the common tangent to the base circle from point B. A and B are the centers of rotation of pinion and gear. So this point is point F. So BF and AE we have drawn. Now we want to find out the path of contact. So for that we'll see what is path of contact. So The path of contact is the locus of the point of contact of the mating tooth from the beginning of the engagement to the end of the engagement. Now the question arises, from where exactly the contact between two teeth start and where exactly the contact between that particular pair will break. So remember this, the contact between two tooth profile will start, or the contact of two teeth is made where the addendum circle of will or gear, bigger one, the addendum circle of will cuts the line of action. So EF is the line of action. So the addendum circle of will is intersecting the line of action at this point, and this point is, let it be C. So at point C, the contact between two teeth will start, and the contact between the two teeth will be broken where the addendum circle of pinion, intersect the line of action. So the addendum circle of pinion intersect EF line at this point, let it be point D. So D is the point where the contact between two mating teeth breaks. So the total CD distance is the path of contact. Total CD distance is the path of contact. So path of contact has got two parts, CP and PD. CP and PD. CP is called as path of approach and PD is called as path of recess. Now we want to determine the dimensions. We want to determine the path of contact in terms of the standard parameters, that is the radius of the gear and pinion. So for that we are going to connect point B and C and connect point A and D as shown. Now I am going to draw a common tangent from the pitch point. I am going to draw the common tangent from the pitch point to both the pitch circles like this. So this line, I will name this line as line TT. So this line TT is the common tangent to the pitch circles. Remember, EF is the line which is common tangent to the base circles. TT is the common tangent to the pitch circles. Now the angle between the line EF and TT, you all know it is phi, which is pressure angle, So this angle is phi. So the angle between EF line and the line of center means this angle will be 90 minus phi. So the angle of EF and T line is phi, so hence the remaining angle will be 90 minus phi. So in triangle PBF, the angle PBF will be phi. Similarly, the angle PAE, this angle will be phi. This angle will be phi. Now let us consider the pitch circle radius of pinion is indicated by small r. So AP is small r, and the pitch circle radius of gear is capital R. So BP distance is capital R. Let the addendum circle radius of gear, that is BC, the radius of addendum circle for gear, let it be capital R suffix A, capital R suffix A, and the addendum circle radius for pinion, that is AD, the radius of addendum circle of pinion, it is small r suffix A. So AD distance is small r suffix A. So for better understanding, I have redrawn the figure again over here. The same figure I have redrawn over here. Now you know that the angle FBP is phi, and the angle PAE is phi. So in triangle BFP, BP distance is capital R, and the angle made by FBP is phi. So in this triangle, if I want to find out BF, side BF, which is adjacent to the phi angle, so it will be in terms of capital R, it will be capital R cos phi. Similarly, in triangle PAE, the angle at point A is phi. So if I want to find out the adjacent side of phi, that is AE, the distance AP is small r. The distance AP, which is pitch circle radius of pinion, it is small r. So AE will be small r cos phi, as it is the adjacent side of phi. Now similarly, if I want to find out FP, if I want to find out this FP distance, so again from triangle BFP, FP is the side opposite to phi angle, so the opposite side will be capital R sin phi. So this FP distance is capital R sin phi. Similarly, in triangle PAE, the side PE is opposite to angle phi. Hence, this distance will be in terms of the diagonal. Diagonal is the pitch circle radius of pinion, which is small r. So it will be small r sin phi. So now we know that the distance BC is capital R suffix A, that is addendum circle radius of the wheel. BP is the pitch circle radius of the wheel. Similarly, AP is small r, it is the pitch circle radius of the pinion, and AD is the addendum circle radius of pinion, which is small r suffix A. Now I want to find out the distance CD in terms of these known entities. So the path of contact is the addition of two path of approach and path of recess. So CD is the total path of contact, and it has got two parts, CP path of approach plus PD path of recess. Now instead of CP, I will rewrite this CP distance as CF minus PF. So CP distance I will rewrite as CF minus PF plus PD, the distance PD I will write PD distance as DE minus PE, DE minus PE. So I am going to write this PD as DE minus PE. Now I want to find out the distance CF. So I want to find out the distance CF. So in triangle BFC, in triangle BFC, I want to find out CF. So if you'll see, it is a right angle triangle. BFC is the right angle triangle which has got BC as its diagonal. So if I want to find out BC square by using Pythagoras theorem, BC square will be equals to BF square plus CF square. So BF square plus CF square. So CF square will be BC square minus BF square, BC square minus BF square. So BC from diagram, BC, this distance is R suffix A, that is addendum circle radius of gear. So RA square minus BF, BF is R cos phi. So minus R square cos square phi. So CF, the value of CF will be root of RA square minus R square cos square phi. Similarly, now we'll consider triangle ADE. In triangle ADE, I want to find out the distance DE. I want to find out this distance DE. So for that, again consider triangle, right angle triangle ADE, whose diagonal is AD. So AD square will be equals to DE square plus AE square. So I want to find out DE value. So DE square is equals to AD square minus AE square. So what is AD? What is AD? From diagram, AD is small ra, that is addendum circle radius of pinion. So RA square minus AE distance. AE distance is small r cos phi. So small r square cos square phi. So DE is equals to under root of small ra square minus small r square cos square phi. So these are the two required values. I am going to put both the values in this first equation. So the value of the path of contact, that is CD, is equals to CF minus PF. So CF is root RA square minus R square cos square phi minus PF. From diagram, PF distance we have already did. The PF distance is capital R sin phi. So minus R sin phi. So this is the path of approach, that is CP value, path of approach plus the path of recess. So this is path of recess, and path of recess is under root of small r suffix a square minus r square cos square phi dE minus now PE. So PE from the diagram, PE distance is small r sin phi. So minus small r sin. So this is the total path of contact. So path of contact has got two parts, path of approach and path of recess. So CD is the path of contact, which is under root of capital R A square minus capital R square cos square phi, which is the term in root, minus R sin phi. Remember this, the minus R sin phi term is not in root. So the first part, this part is the path of approach. The second part is root of RA square minus R square cos square phi minus R sin phi, which is the path of recess. So this is the total path of contact.